Thank you. Good afternoon to everyone. Now we will change a little bit the topics. We will talk about practical environmental sampling during an on-site, and how can we assess how many samples, the number, and also the quality of the measurement that we can achieve during an on-site. Let me introduce something. You know, I know that all of you already know, but the constraint of an environmental sampling in the context of an OSI can be very, very complex, because the underground explosion happens inside a geological structure that has very complex features, and the explosion itself can create different fractures. And so we have to deal with some complex geological formation, and also we have to know what are the transport modeling of the gases and the particulates that are created in the cavity and moving to the surface, because we will do the environmental sampling on the surface, also below the surface, but we will do this environmental sampling in the context of a geological environment. And the other things that we should take into consideration is that the plume after a nuclear explosion can be in a different shape, can be intermittent, can be permanent, and so we can have some different features also of the plume. So when we are dealing with an on-site inspection and environmental sampling, we should answer to this question. Does my samples give me the most reliable pictures of the phenomena I'm observing? And does my analysis give me the most accurate picture of the sample that I'm going to measure? And the last question was, how many samples do I need to be able to measure in order to have a realistic and achievable picture of the phenomena that I was monitoring? So we have to consider a lot of physics regarding the radionuclide production, the transport. These are the prerequisites for the sampling. We need also to consider the quantity of the material that we are available for the detection. You know, the IMS station measures different quantity of material compared to the OSI. And we need also to take into consideration some statistical methods for sample size calculation and the number of measurements that we needed to achieve our desired level of confidence. And after, at the end, we should also consider some practical consideration, like the logistic of the laboratory, the personnel, how many people are working, how many detectors are working. So there is a lot of constraint regarding these decisions. And after, we need also to deal about what we think that is an anomaly detection. We have a very general definition of the anomaly detection in an on-site that can be defined as a localized area in which the residual activities concentration of some OSI-relevant radionuclides exceed some threshold. And so the objective of the environmental sampling and also of the lab measurement is to detect with confidence these areas of anomaly. But this detection, again, depends on different factors, like the difference between the anomaly concentration and the background concentration, so the ambient concentration. Also on the specific detected OSI-relevant radionuclides we are searching for. And also it is heavily influenced by the sensitivity of the instrument that we have. And now we have also to deal with the statistical in our decision. Briefly, we can make mainly two main errors in the statistical decision about a measure. We can have a false positive, and we can have a negative positive, a false negative. If we do a false positive in an on-site, which will be the consequences? We will end earlier the inspection. We will have a wrong attribution of the violator and on the violation, and we lose credibility of the OSI regime. If we have a false negative, we will have an extension of time of the inspection and also the related cost linked to the inspection. We will arrive at a wrong conclusion, and again, we will lose credibility of the on-site inspection. So this is very important to have all these things in mind when we design a sampling strategy. And which type of sampling we can do? More generally, we can have three basic types of sampling. A systematic grid-based sampling, in which I will create a grid a very geometrical grid, and I will take each sample from each unit. We can have a simple random sampling, so I have still a grid, but I will choose some sample in this population. So every member in this population has the equally chance to be selected, but not all are going to be selected. Or I can have a judgmental or biased sampling. So it's not a statistical method, obviously, but can be used when it is applicable, and it's chosen based on the expert judgment. I must say that a purely random or systematic approach for the sampling in your site is really impractical or inefficient, because the area is very large. We cannot have any systematic grid base or also even simple random sampling. So we need now to think about the sampling plan, and I have listed some of the parameters we should take into consideration. We should take into consideration which are the minimum detectable activity for our OSI relevant radionuclides, and it will determine the concentration that can be reliably measured. We can have the threshold concentration that allow us to detect an anomaly and so to give some sense about the hypothesis test. We have the critical limit that is something that is coming from the statistical application during our measurement. And we have the two types of error that we can make in the checking of the hypothesis. And so again, we can decide our desired confidence in the selection of the hypothesis. And in this case, we will have an increase of the number of the sample that we need. Or we can have also, we want to have some, to increase the desired power of my judgment of my hypothesis. So the probability of raising the level of interest of some search zone. And again, these parameters will increase the number of samples. Or I can also determine the width of tolerance between the range of concentration. And obviously, this will decrease the number of the sample site. We also have to deal with the site variability, and in a geological, in an environmental area, obviously we have a big site variability. And again, these parameters will go in the direction of increasing number of sampling. So what will happen in a real test of an inspection? We can have a very preliminary scoping sampling in which we search for a large area in order to have an indication about the level of interest of the zone. And so we will have a quite huge number of samples, but that can be constant for the very, very first day, because we need to identify and prioritize the level of interest. After, when we have made this prioritization of the search zone, we can have some characterization sampling. So we focus on some search zone, and so we have an increase of number of samples, but they are coming from the same search zone. So we are trying to characterize the sampling till we detect what we want to search, an anomaly or not an anomaly. And after the final sample, just to collect some more sample in order to have to give a statistical value of our decision. And so at the end of the inspection, the number of samples really will drop down. I will show now some case study, and in which we started 20 years ago with some quite random sampling, and in which we identified some search zone. After we selected that with the green zone, we are interested in this green zone because it was a research about the content of cesium-137 in a lagoon in the north of Italy. So we know that is the source, and we identify this zone because it's the zone that has much more variability during the period. And so we focus on this zone, and we keep going to test this zone along the years. And so we started from a random plus a judgmental plan because we know the source, so we make the sampling around the coast, very near from the source in which we are thinking that the cesium-137 is coming from. And we go to the judgmental sampling. Why? So we measure only 10 samples from the same zone. Because we have low capability in the laboratory, we want to reduce costs because now we understand much more the phenomena, and so we we change from the random sampling to a judgmental sampling. And now we'll show you some results about the direct exercise that was made in 2023. So we have almost measured, collected and measured 9-10 particulate samples plus 6 in situ gamma spectroscopy. We have a very small lab capability. We have only 2 detectors working, not very well. We are still in the testing period. And so we decided to make this systematic grid sampling. 10 samples distributed all around the search zone. And so this was an example of scoping sampling, so narrowing down the search logic in order to identify search zone. And after, I will give you the example of the integrated field exercise in Jordan in 2014. We have already making the narrowing down of the area to some specific search zone with other techniques. And then we focalize on a specific search zone, and we collect 130 particulate samples. And we were able to identify different type of sample with different level of interest. And so at the end, we were able also to narrow it down to a very, very specific zone in which we also ran some in situ in order to assess and to determine the final location of the anomaly. So with this number of samples, we were able to exclude some search zone and to arrive to a decision. So it was the demonstration of our hypothesis. So the workload of the lab in this case was very intense. We have 4 detectors running completely, but it was affordable, so we were able to do this. So what are the conclusions of this type of picture that I want to give you for the sampling? The inspector should know very well the source term, so they should analyze what is the source term. They should know the phenomenon that is related to this source term. And so this step is very important because it can provide us the threshold that we want to use, and also the models, the statistical model that we want to apply. We should define after the risk and the objectives of our search logic. And so what are the acceptable errors that we are going to have? After, we should take into consideration some technical aspects, so the MDA, the minimum detectable concentration, the critical level, and also the statistical framework in which we want to work. And only after having into consideration all these parameters, we can design a sampling strategy, choosing the most appropriate, coming from the random grid sampling. If it is a scoping, we are still in the very beginning of the inspection, going to the judgmental sampling. Now, going to the very basic information that I want to give you is how many samples do I need to collect during an on-site? So we can use very different statistical method, but we should also compare with our technical capability. So as a rule of thumb, I can say from my experience, the experience of my lab, of my staff, that if we are able to collect 5-8 samples per day, this is a number that is realistic to collect and also affordable to measure in the lab. This means 160 samples in the first 25 days of an inspection. In order to do this, we need to have a plan of the laboratory. So we need to have a very clear planning of the different steps for the collection and for the analysis. Also because we need, at the end of the day, also ensure the data quality of what we are measuring. And at the end, also the expertise of the inspectors and also the procedures, the very detailed procedures are very important in order to be credible for our sampling strategy. And I will end also to launch a challenges for our last speaker. I will also have I would like to have some discussion about how this approach can be integrated in the inspection team functionality. Thank you.
Thank you, Dr. Rozzo. So the floor is open. Please. For the time constraints, we are allowed to have no more than 2 questions. So please.
The question is, you demonstrated isotope cesium-137, which at my time was not relevant to on-site inspection because it's 30 years half-life, and only with combination with OSI relevant, it would be indicative. And this is just radioactivity, and the world background of this isotope is very high. So, or you just
I use this
as an example.
As an example because of sampling. We need to. We want to analyze how to make a good sampling plan. So it was just an example, obviously. Yes.
And my comment on the beginning of your presentation, you mentioned that well-contained events, explosions would not release at all. I a little bit disagree because the noble gases which do not interact with the environment and earlier or later will be released in particular, of course, and MDA now are so good, so low, that's, I hope that xenon isotopes, well known, would be released in particular when atmospheric pumping happened, when the underground pressure of air is higher than and follow the atmospheric pressure, and that's the effect of atmospheric pumping. It would come outside, and with existing MDA could be measurable, and also argon, where if calcium is present there. So, and my recommendation to start with noble gases because there are several other fission products relevant to OSI with a half-life several days to several weeks, and xenon from 5 hours, I remember, to 5 days to 11 days, and 35 days argon. So that's, I think, the focus, in particular atmospheric situation, should be on noble gases. Thank you for good report. Thank you.
Yes, you touch exactly a very, very important point, but this presentation was really related about the particulate sampling. Maybe I did not explain it very well at the beginning, but you are completely right. Yes, the noble gas sampling is something that should lead also the search logic. Yes.
One more question. Is there? So thank you very much.